Why, hello there. This is that video I promised about writing safe C code. In this video, I'm going to tell you some of the tricks I've compiled and figured out on my own how I write code that is safe in C, and I'm going to share them today. So without further ado, let's get into it, because so let's do it. Alright, so I have this repository here called Safe C. I called it this on purpose. I wanted to make the people perusing the internet think this was a programming language and then click on it and get all excited and they're like Rust zealots or whatever. But no, what this repository is a bunch of examples on how to write safe C code. I have some things here in my README, so I talk about my compile all.sh script a little bit. I have a makefile, which basically just wraps around some basic commands and the compile all.sh script. I talk about compiler flags here. So I talk about wal, where, wextra, pedantic, the standard flag, and pthread for compilers like GCC, and fsanitize for asan and ubsan and lsan and whatnot. I also talk about some other tips like asan and ubsan down here explicitly. I talk about reading man pages because some functions, like for example snprintf, is not guaranteed to null terminate the string that results from it. So, for example, you want to read the man page about the functions you are using in C. Avoid undefined behavior. Arenas and explicit lifetimes. An arena is basically a way to lump a bunch of stuff into a single lifetime. There's a little more to it, but that's how I would define it. It's basically one object that tracks a lifetime of a bunch of other objects, and then when you free that arena, it automatically frees all the things it's tracking. I also talk about naming your functions. So, for example, if your function returns a malloc pointer, meaning it has to be freed with the free function, put that explicitly in the name of your function. So put underscore malloc somewhere in your function so it's clear that what it's returning needs to be freed with free. Prevents memory leaks. I also talk about using assert from the assert.h header, where assert.h is a header that provides this assert macro that generates code in debug mode, where ndebug is not defined. If you define the macro ndebug during compilation, assert does not generate code. But what assert does is it crashes your program if whatever expression is inside of it evaluates to false. I also index versus pointer storing. What that is essentially if I have some C, so I have this struct that is stored somewhere in my program. Don't worry about the nitty-gritty of how this is stored or whatnot. Let's say it's a hash map or a vector or something. So let's say this struct is the data type for a child that is stored in some complex heap-based data structure, whatever. So you have a bunch of these, and what this does is it stores its next. So kind of like a linked list, except there's this whole central object managing all the children. You could do something like foo next, and obviously because this is a C and it's self-referential, you'd have to do typedef struct foo like that, and then have this as just struct foo. This essentially does the same thing, but allows you to reference itself as a pointer. You could do this. The problem is, with heap-based storage methods, if you use, for example, the realloc function to reallocate heap memory, to get a bigger chunk of heap memory or whatnot, this pointer will become a dangling pointer. It will no longer be valid. Whereas what you can do instead is store an index to the next child. If, for example, this is a bunch of data being stored in a vector. And I understand what I just said sounds a little rambly, and you guys might be a little lost. Essentially what I'm trying to say is avoid storing pointers in your structs if you can get away with instead storing an index. Essentially, instead of storing a memory address, you want to evaluate what the memory address is every time you retrieve the stuff to avoid dangling pointers and dereferencing those and getting a seg fault or worse, silent memory corruption. So yeah, store indices whenever possible. Also talk about conditional compilation for compiler built-ins. This is, for example, I have an example here, printf format function. And what this is doing is it's checking, actually I can show you guys like in my nice environment. Coding C, or where did I put it? Safe C, yeah, right there. So in examples I have this printf format function.c. What I'm doing here is I'm checking to see if the compiler is GNU, GCC, or if it's Clang. And if it's either of those, I define this macro that basically redirects to an attribute built in and passes a bunch of stuff here. And indexing starts at 1. I have no idea why. It's kind of a weird decision, but anywho. And if none of this is met, so my program can be compiled with any compiler, I just define a little backup here that generates no code. So like for example, if TCC is compiling this, it won't throw compiler error saying like, oh, macro not found or whatever. So I just have this here that generates no code. And then I have a little function here that utilizes that macro by basically being a wrapper around printf that also accepts a formatted input. So I have my format string here, and then my variadic arguments come after that. And I'm using a std_arg to create a VA list. I'm starting that VA list, ending that VA list. And then I'm printing out a little prefix, printing out my formatted output, and then printing out a new line character. Then I have my main function where I'm using that function to say hello world, creating a integer variable, and then I'm doing integer is equal to, and then passing in formatted data here. And yeah. I also, yeah, so that's that. And then I also talk about macros. This, I guess this is not as clear in the README as I'd like it to be. Basically, what I'm trying to talk about there is, let's say you have some C code. I need to set language C. Let's say you have some C code. I'm going to create an array here, and then I'm going to create another array here. And one is not the same length as the other. Notice that. Now, I'm going to include stdio. And actually, I also need to make these not the same data type. Now, I'm going to iterate, and let me pull in stddef for size t. Now I'm going to iterate through array 1. And I need to, size of R1, 0. So, for those who are not familiar with this style of getting an array's length, essentially what this is doing is the size of keyword in C gets the size of whatever you pass to it in bytes, but an array is basically an array of bytes. That's what it is, but it has a type. And that type can be a byte long, or it can be more than a byte long. Like for example, on my platform, an integer is 4 bytes big, and a long, I believe, is 8 bytes big. And that means this array in total with 5 elements is what is 4 times 5? That is 20. So this right here, if I took a size of array 1, I would get 20. 20 bytes is the size. and then I take a size of the first element. And fun fact, this does not get evaluated. The size of is a compiler directive. So even if this was an invalid memory address, me taking the first element of array 1 and getting the size of it works because it's at compile time versus run time. So I'm getting the size of the first element of array 1, which is the size of an integer, which is 4. What is 20 divided by 4? It's 5. So the array length is 5. And I'm just iterating through that, and I'll get my element, which I'll just say is array1I, and then I could print that out. So element, and I could do that. I also need to return 0. So if I were to compile this, and I guess I could compile it, example.c, gcc tech o, example.c wall where wextra pedantic stdc99. Right, and I just need to say that array 2 is unused. And this actually kind of ties into one of my points about compiler flags, is it will catch warnings like this, which could actually be errors. You could type something incorrectly. When you mean to use a variable, you end up using another variable that you did not mean to use. So that unused error will tell you about that, and then you'll be scratching your head and you'll figure it out. So, yeah. These flags are very important for developing safe software in C. And yeah, so it works as you'd expect. Now, let's say you wanted to actually use array 2. You might do something like this. You might access, You might access array 2 instead and be like, okay, I want to use array 2. So you do this instead, but you forget to change this. Now, the compiler is warning me about this because I have those flags. Or actually, this is separate. I'm pretty sure that's actually just the LSP is configured to warn me about that. But now, if I see, okay, compiler flags saved me once again. Let me actually remove all those compiler flags. Okay, it compiles because I removed all these safety-oriented compiler flags, and now I'll run it. And I get totally wrong values, and why is that? I forgot to update this right here. Now it will work. Exactly, it works. Now, there is a better solution, and that is to use a macro. So let me define a macro up here called array len. And let me take the size of x divided by the size of x's first element. And then what I can do here is, instead of taking the length like this of R2, I can take the array len of R2. Not only is it more readable and elegant, it's also safer, because now I only have to update this in one place, and I can do something like this to see what it expands to. Oh, yeah. You see, it's the same general output. It works the same way. And yep, so that's what I mean by using a macro. You can also extend this macro idea a little further to make your code more readable. So for example, I could define this unused keyword's fake little keyword that's just void, and then instead of casting to void here, I can just do unused. And look at that. I invented my own little keyword, and now I'm using it, and it just works. It just works, because you see it expands to void. Yeah. So that's that for macros. And I actually talk about this fake keyword approach too a little bit in my repository. So in examples, and yeah, so you should also trust your compiler's optimizer, and readable code is better than fast code, in my opinion. I added that to the README just because you know what. Fake keywords, yeah. So, fake keywords, I talk about that here briefly. I will also have this repository linked in the description if you guys want to check it out or even contribute. I am super open to contributions. I want more and more examples in here on how to write safe C code because C has its place in the world. It's an incredibly portable language. So if you can write good software in C, your software is probably able to compile on more operating systems than most modern languages and whatnot. It's just, yeah. Knowing C, knowing how to write good C is a very useful skill. It will also teach you how to write better code in other languages. Because you'll learn about, like, for example, the new keyword in C++. It allocates heap memory. Heap memory allocations can actually fail, but C++ hides that away from you. It's also more intentional in C. So as opposed to using a little keyword that's 3 characters long like you would in C++ that hides the failure away from you in maybe an exception or something where you have to try catch or whatever. I don't know what C++ does. In C, you have to use a 6-character long function name, malloc. You call this function that's very intentional that it's a function, and then you check the return type to see if it's null, and that's how you know if it failed or not. Not everyone checks for null. That's fine. On Linux, you actually don't need to check for null because Linux does something called overcommitting, where it tries to give you memory no matter what, even if it means killing a process. But yeah, malloc can technically fail. So you want to check that. And yeah, you just learn how to write better code if you know C and you write stuff in C. I also have an arrays example in here for how to write array wrappers, because that's something, for example, Rust programmers like to dog on C for, is the fact that its arrays are literally just sizeless pointers that you can arbitrarily access. And yeah, it is. But let me show you what I got here. So I got this rlen macro, which I called it rlen instead of arraylen to differentiate it from my little array wrapper. And let me actually open it in my text editor. So I always have a little description up here about the example. I have my rlen macro, which I already talked about, my unused macro, which is like a fancier version of that unused fake keyword I showed you guys. In fact, this macro is probably a better solution because it wraps everything in these parentheses, which the thing about C macros is it's literally a copy-paste of altered text into where you call the macro. So putting parentheses around the entire expression of a macro is a good way to avoid precedence bugs, where the parser parses something before another thing and that is deeper in the tree. Look up abstract syntax trees if you want to know more about what I'm talking about. I have this macro to compose array types. So you can compose a constant array type and a mutable array type for whatever type is passed in. I'm composing array types for the character type in C. I have this generic function arrayGet, which is not used directly. It's used in a macro to make things easier. But it takes a void pointer to the underlying array, the count of elements in the array, the type size of the underlying elements of the array, the index you want to access, the line of code that the macro was called at, and the file the macro was called at. And if index is more than or equal to count, right, because if count is 2, your index must be 0 or 1. If it's 2 or more, it's out of bounds. So if your index is out of bounds, I print a little message to stderr as per the standard, because error messages go to stderr, regular output goes to stdout, and I just print this bad array access on line, put in line of file. I print the index and the count, and you'll see I'm passing all of that here, and then I just exit the program. crash the program, abort it, you know. Red button, boom, and then or whatever sound a red button makes. And then I get the element by casting that void array pointer to an array of bytes. This is because if you do pointer arithmetic in C, it automatically takes the underlying pointer's type size into consideration. So I cast it to a type that only has a size of 1 byte. So this arithmetic is as is, because you're timesing 1. So I offset this array by index times type size, and that's my element pointer as a void pointer. So if I dereference this, I will get the element at that index in the array. And then I return element, and that is my little function to get the element pointer, basically. And then I have this wrapper function for the constant version that just does some casting stuff under the hood. It just casts this constant pointer to a mutable pointer, but since this pointer is not actually mutated, it's okay. And then I cast it back to a void pointer. Yeah. So then I have these macros that wrap around it. So the array const get pointer, I use a C23 feature here called typeof, and what that does is it takes a type of my array pointer. So in this case, for a character array, for example, that would be char star, character pointer. I cast whatever the void pointer gotten here. I cast that to that type, so it's back to a typed pointer. I pass in the array's underlying array pointer, the count, the size of one of the elements. This should be pretty familiar to you guys. It's pretty simple. I pass in the index, I pass in the line and the file, as I discussed above. And then I have the same exact macro, but instead of array const get, it's array get. And then I have this array get macro, which basically just dereferences whatever you get back. And I'm using array const get here because in C you can implicitly cast a mutable pointer to a constant pointer with no compiler warning or error. But if you do the inverse, you get a compiler warning or error. So this macro will work on both constant arrays and mutable arrays. I also have this array literal macro, which creates an array wrapper from a literal. So if you do like the curly braces and pass that to this macro, it will do all the magic for you to create that array wrapper instance for you. And then I have a char array literal, which takes a string literal and creates a character array from it. And you can see I'm using that down here. And then I'm just printing all the characters in that array. And then I have a thing to test my array bounds checking. Down here you can see I'm accessing the 100th, or actually the 101st element, because, you know, 0 indexing. So I'm accessing that, and if I compile all these examples and run it, build arrays, you'll see that I get that error message, bad array access on line 108 of examples arrays.c, index 100, count 15. Pretty cool, right? My other examples I have, arrays, fake keywords. I'm saving this one for last, and it looks like I do actually have to look at it now because that's the last one. Is the goToDefer. This is how you can guarantee resource cleanup in C. You don't need a dedicated defer keyword, you just need goto. I know, before you guys vomit in your mouths, I am using goto, but just hear me out, guys. Just hear me out. This goto is beautiful. I might even start tearing up how beautiful it is. So, I'm including a bunch of stuff to give me some functions, whatnot. So this is a example function I wrote, which just either returns true or false. It's completely random. The idea of the code is that this function can sometimes fail, so all code paths are guaranteed to run eventually. And then I have this other function which, yeah, you get the idea. It's just, it does the same thing by calling that previous function, but you are supposed to pretend that it's another function that can fail. And then I have my main function where I create this exit code variable at the top. And it's used in the end and fail labels, so the value here must be something that is guaranteed to be a valid value. It cannot have an error path. So you cannot call a function that could fail in order to set this variable to a value. It has to be something that's always going to be a value. It cannot fail. So for example, exit success is a constant value, meaning it's always there. It's guaranteed to be there. Same with null. It's a constant value that's guaranteed to be there without running computation that could fail. So I'm declaring these variables up here. And then I have this scope. And the reason I have this inner scope is to protect variables that might be uninitialized from the labels. Because if you, for example, define a variable down here, this code up here has this fail goto, meaning this variable probably, like, there's a chance this variable never gets created and initialized. But if it's not inside of the scope, it can still be referenced in these labels, which means it could be uninitialized and still referenced, which the thing about garbage values on the stack is they're non-deterministic. So you can see how that can be a big problem. So I have this scope. So anything that has a fail path must go inside this scope. Anything that's a variable that will always be initialized by the time these labels get called, those go outside of the scope because they get used in the labels. It also is just more readable, like it's clear these variables get used inside of the labels because they're outside of the scope with intent. So I declare these out here, and then I have my labels themselves. The end label checks to see if S is not null, close S, the file, close the file S, and then return exit code. And then below end, because control flow goes from top to bottom, and I'm returning here, so it's okay to put labels under end. I'm saying the fail label sets exit code to exit failure, and then simply calls end. It goes to end. And yeah, so end is where you put all your cleanup code. And then inside these braces, I have my actual logic. So I do something, if something fails, I print an error message and then I go to fail. If that succeeds, I move on, and I say s is equal to fopen hello.txt in read mode as text. And if s is null, I print an error message, go to fail. If that succeeds, I print out whatever's in the file, and then I try to do something also. If that fails, I print an error message and I go to fail. Pretty standard stuff, pretty easy to understand. Let me run this example. So I'm going to build go to defer. Failed to open file. So do something succeeded, but opening the file did not. So I'm going to create this file, and I have in my git ignore this file, so that's why my git status is not changing. So go to defer. Failed to do another thing. And there's this new line here too because it read the file. So let me actually put something in here. Hello world. Hello YouTube. Please subscribe. Subscribe. If you enjoy this video, please subscribe. It means a lot to me. I'm even wearing the Linux shirt, guys. Don't you think I'm cool? Don't you think I deserve a subscription and a like? It's your choice, guys. No pressure. But it does help me. The thing I care about most, though, is that people know who I am and find value in my videos. Um, so go to defer. As you can see, I don't know why it's not. Oh, I think I forgot to write all that. So as you can see, my code is running it. Everything succeeds. And resource cleanup is guaranteed. That file is guaranteed to be closed because I have it in my end label, which is always hit, because instead of returning directly from the function, I use goto. I hope that makes sense. So that is mainly my tricks for writing C in a safe way where I don't get weird stuff like seg faults, race conditions, and whatever else. I hope you guys enjoyed. Um, if you guys have any questions, leave it down in the comments. I have a Discord server at my website, oglo.dev. You can go down to my links. I have my GitLab repositories, Codeberg repositories. I don't use Codeberg anymore, so the stuff on here is just old stuff I haven't migrated yet. I have my YouTube channel, my Discord server down here, my subreddit, which is completely dead, and probably you won't be able to post in it because Reddit locks a subreddit if no one's moderating it or whatever. So yeah, join my Discord server if you have any questions. You can also shoot me an email or DM me directly on Discord. Feel free to ping me, DM me, whatever. I actually like that engagement to start a conversation. I like talking to people, which is quite unique for Linux YouTubers, it seems. And yeah, so this is my website. Check out my links, whatever. Subscribe, like, leave a comment regardless. Helps the algorithm too. And I hope to see you guys in the next one. And by the way, guys, I got a little taste for you too. I'm making a Linux distribution, so stay tuned for that. And it has a reason to exist too. I'll talk about it in the next video about the Linux distribution. So I'll see you guys next time. Bye-bye.